Some time ago, this chart of Slack's notification system went viral because people were surprised by how complex it is. So if you send a message here in Slack, let's say blah blah, if I now press enter here, there's going to be a request to the Slack server. And if there are other participants in this chat, Slack will decide whether to send a notification to them according to this flowchart. So it starts here, should we send the notification? Well, is the channel muted, yes or no? Well, even if it's muted, maybe there's some thread message and the user is subscribed to that. And then it goes down all the way here with all of these options, eventually resulting in a final yes or no decision. Why am I showing you this? Because I want to show you that bigger companies structure their applications differently than maybe you are structuring them. So I quickly want to explain to you what this debate about Monolith versus microservices is, and then what Docker is, and then why you would want to use something like Kubernetes. But Kubernetes is very complex, so there is now a solution called Acorn that makes it super easy to deploy apps to Kubernetes. Acorn is also the sponsor of this video. The team behind this are some big names from the Kubernetes world, and they have come up with a platform that makes it super easy to deploy apps without knowing anything about Kubernetes. But before we get there, why would we even think about Kubernetes? What is even Kubernetes? What is Docker? What is this microservices? What is a monolith? So as a developer, you may be creating monolith apps. So if I have a user here, and here I have my app, and this user or the client may send requests to my app. And when a request comes in, I want to run some code. So if we take the example of Slack, maybe there is some code here that relates to sending a notification, right? Notification code. And maybe there's also some code related to just messages, actually sending the message to somebody else. And if the user signs in, maybe there is some authentication related code. And maybe the user uploads an image and we have some code related to that, image upload code. And I could keep going, but I think you get the point, which is that we now have one big monolith app. So all the code is contained within one big all-in-one app. And this is fine for smaller apps. But what you're going to see in the real world is that especially bigger companies, this is not how they structure their applications. And there's a good reason they don't do it that way, because this has many downsides. For example, if we look at the notification code, you can see how complicated this is in Slack's case. So it's possible that there is a team dedicated to dealing with this notification code. So there is a team working on this, but then there's maybe also a team that's working on authentication code, a different team or different people. And now let's say the people working on the notification code, maybe they made an update and they want to redeploy the app. Well, that's a problem now, because if they want to deploy the app, it's going to interfere with the other people working on the app. Because it's one app, you're going to have to deploy the whole app. So this may interfere with other people's work that are working on other parts of the code. And maybe the people that are working on the notification code, they want to use Java as their programming language. And maybe the people that are working on the image upload code, they want to use JavaScript. Well, that's not really going to be possible because this is one app. You're going to have to pick one programming language. And there are many other issues with this monolith setup as well. So instead, what you may want to do is split this up into separate microservices. So basically little apps. For example, if I zoom out a little bit here, I can create a separate little app here just for the notification code. So I'm going to put it in here. And instead of calling it code, I could call this service, notification service. I will just call it notifications for now. And then I also could have one for the image upload code, another little app essentially, and another one just for the messages, and then another one for, let's say, the authentication, right? Just for all the auth related code. Now the client will not directly send a request to each of these services. It will just send it to one place, which will route it to the other services. When I say service, it's just a little app essentially. So I will just call this router, and then this will decide where to send that request to or which services to invoke. Maybe for a particular request, it needs to use both the notification service as well as the auth service, because maybe the user logged in and we want to notify somebody of that. So this is starting to look more like how an enterprise company would deploy their apps. And I used Slack here as an example, but for example, Spotify gets millions of requests and they have teams working on different parts of the software. So in Spotify, for example, there could be a service called user activity, just keeping track of what the user is listening to. And then maybe they have another service for recommendations, right? Which songs to recommend. And there could be many more. There could easily be a couple dozen services or little apps that a big company is using instead of putting all of that in one big app. And these services may also be talking to each other, right? So for example, the recommendations are based on the user activity. So they are in contact in some way, which makes sense because if the user is listening to a particular genre of music, you probably want to recommend within that genre of music. Now, obviously, this is going to increase the complexity. So why does this justify that extra complexity, especially for large companies? Well, there are many benefits actually. So the notifications team can work in Java. And over here for the recommendations, maybe they do a lot of work with machine learning, and machine learning has a lot of Python. So the people here want to use Python. And the people working on the image uploads here, maybe they're using a third party for images, and the third party has a really good library for JavaScript or in JavaScript or TypeScript. So they want to use JavaScript or TypeScript here, which is possible because these are their own isolated little apps. So you can pick your own programming language. This is also really beneficial for big companies for recruiting, because if they're using one programming language, they can only find programmers that are working with that specific language. However, now the programming language doesn't really matter. It's up to the developer essentially. So very beneficial for recruiting new developers as well. It also makes everything much more efficient in terms of using compute resources as well as cost. Because let's say there is some big event happening and people are suddenly sending each other a lot of messages. That means we want to assign more compute resources to this messages app or service, but not to anything else. And maybe also for notifications here, but not everything else. So we just want to increase compute resources for the messages service and maybe also for the notifications service or app. But let's say that everything else can stay the same. So now we don't have to scale up our entire app, only the services that actually need it. So if some services aren't getting much traffic, for example, image uploads, maybe you put that behind a more expensive plan. So only pro users can upload images, let's say, and maybe that decreases the load in the image upload service. Well, you can simply scale it down without scaling the whole app down, right? So you become very efficient with compute resources and cost. Another big benefit is that they can be deployed independently. So let's say the notifications team, they found some bug here and they need to quickly fix this bug. So they fix the bug and now they want to deploy it to production. They can do that without interfering with any of these other services. And so they can just deploy while the recommendations here will just not be deployed again. And what if there is some bug in the user activity service and it crashes this service? Well, now this will fail in isolation. It won't affect the other services. And especially with user activity, for example, this is not even a service that's really necessary to use the app. So it's nice that this fails in isolation without affecting the rest of the app. The rest of the app can still continue. If you had a monolith all in one, this could crash the entire app. Also, let's say this image upload that we were talking about, that third-party library that you're using for image upload, maybe it only works with Node.js version 18, let's say. But maybe in some other service, you want to upgrade to Node.js version 20. Well, now you can already upgrade this one without affecting this one. This one can stay at version 18. Maybe that's necessary for some third-party library. So you can upgrade versions without affecting the other parts of the system. And I could keep going. There are other benefits. Let's say the messages, you push it to production and there's a problem. You can roll this back without affecting the rest of the app. So there are many benefits of splitting up your big monolith app into separate, smaller microservices. And that's why, especially in big companies, enterprise, you're going to see this structure a lot. And now maybe there's a problem. After an image upload, there is no notification being sent. So maybe somebody from the notifications team, they want to run this image upload service on their own computer. So they're going to get this JavaScript code on their machine and they will try to run the JavaScript code. But you need a JavaScript runtime like Node.js to run that JavaScript code on your computer. And since that person is working only in Java, they may not have that Node.js runtime installed on their computer. Or maybe they do have it, but it's a different version. And that's only Node.js. There could be other dependencies as well that they have not installed on their own computer. So to solve that, we can use Docker. We can Dockerize this application, as it's called, which basically means we're going to create a container. And in that container, we will have the actual app as well as the dependencies it depends on. So it would have the app as well as the Node.js runtime in this example. So then that other person can just run the Docker container without worrying about installing the Node.js or other dependencies. So Docker makes it very portable. And there are other reasons for using Docker as well. But Docker essentially just separates this app. It isolates the app from the machine that it's running on. And that improves portability. So we're going to Dockerize all of these little apps or microservices. Another word for this is container. So we're going to have a container for each one of these services. So now we have all of these containers and we need to manage them. And we could manage this manually ourselves. For example, we could manually just monitor or check these services to see which ones are getting a lot of traffic. And for example, if we see that the notification service is getting a lot of load and is close to maxing out the machine that it's running on, we may want to decide to scale this up. So we could simply spin up an equivalent service somewhere else on another server and maybe another one on another service. So this is horizontal scaling and we could do it ourselves manually, right? We can just spin up a new server and just create another instance of this service. You could also do vertical scaling, which is just making the machine that it's running on more powerful, right? With more CPU, more RAM. am, right? And you could do that yourself manually. And now let's say that this user activity service still has that bug. It wasn't solved properly, so it goes down again. Well, you could be manually monitoring everything and you can see that it goes down, and you could just manually spin up a new server and so spin up another instance of this service to get it up and running again, right? So you could manually monitor everything yourself, but it's more convenient to use a tool that can orchestrate all of these containers for you. And that's where Kubernetes comes in. So Kubernetes is the most popular container orchestration tool. So some of the things it can do for you, for example, is automated scaling up or down. So if the notification service is getting a lot of load, when it reaches certain thresholds of usage of the machine, let's say, it can automatically scale this up or down. Or let's say that this auth microservice is running on a server and the server is malfunctioning or just not working properly. Well, you can duplicate the service, or maybe you already had multiple instances, and Kubernetes can just reroute this to the healthy node. Also, let's say we're working on the notifications service and we're updating it. When you update an app, it will stop working for some time while it's being updated and restarted. So to prevent that downtime, Kubernetes can automatically spin up another instance here, route the traffic to that one while this one is being updated. And after some time, this one has been successfully updated. So then it can just go back here again and just delete these resources again. So you can update your app without downtime. Right, so Kubernetes is a very powerful tool to orchestrate this whole system to make it really resilient, which is very important to especially big enterprise companies. When you have millions of users or millions of requests, or there's a lot of money at stake, even a little bit of downtime is very costly. So you want maximum robustness. And that's why you'll often see a tool like Kubernetes being used in large enterprises. All right, so then we get to Acorn here, because the downside of Kubernetes is it's very complex. So if you ever try to look into it, you probably saw how intimidating it is. There's so much to learn. And that's actually why Acorn was created. So Acorn comes from a group of people that actually are some big names in the Kubernetes world. If you are familiar with Kubernetes, you've probably heard of Rancher. And the idea behind Acorn is that you can deploy your apps to Kubernetes without all of that complexity, and Acorn behind the scenes will take care of all of that Kubernetes infrastructure, so that you as a developer can just deploy to Acorn without worrying about all of those Kubernetes concepts, so that we can get all of those benefits from using Kubernetes without worrying about that complexity that comes with it. So I want to show you how you can get those benefits from Kubernetes without using Kubernetes by just deploying to Acorn. Now, I don't have 7 or 10 different apps here to show that. I'm just gonna have one app for now. And let's say that's a Python app, it's a Flask app, and you don't need to know Python. I could have also used Node.js or Next.js, which is essentially just a Node.js process, or Java. It works the exact same. So if we take a look at this app here, what it does, we can see that it's going to connect to a database. So a database, in a way, is also a service. So what we can also do is have our database actually also just be a service, right? And we can also Dockerize that and then also deploy that with the rest of our microservice. And that's actually what we're going to do here. So this app will connect to a separate database. So we have some environment variables here. Now, what does this app actually do though? So here, if we look at this, there is a web server here. So when you go to the home page, it will query all the to-dos from a database. It's getting all the to-dos from the database, and then it will pass that as a variable called to-do list to the template.html file. So that's right here. So if we go in here, we can see that here it's looping over all of those to-dos and it's outputting that markup. Right, so very simple Flask app, very similar to how you would do something like that in Express, for example, in Node.js. I'm using this example because this is what you'll see on the Acorn website, and I really like this example. So I will just walk you through the example that they also give you the first time you go through the docs. So here we also see some routes for adding and updating a to-do, and then also here one for deleting. Okay, now we don't really need to know exactly what's going on here. It's just a Flask app, and what we just learned is there are benefits to making that a container. So we're going to Dockerize it, and you do that by creating a Docker file. So if you remember, we use Docker so that we can bundle this app with all the dependencies that it needs, so it can be run everywhere. It's very portable. So in this file, we will put all the things that it needs. So it needs Flask, Flask SQL, Alchemy, and PyMySQL. So you can see here in the app code, those are the things that we're indeed going to use. So our app depends on that. So that's what we put in this file. And then we can Dockerize our application here by creating a Docker file And here you can see we are referencing those requirements. So from this Docker file, we can build a Docker image, as it's called. And that image will be on some registry somewhere on the internet. So then if somebody else wants to run this app, the other person can just pull that image from the registry and run the app regardless of what operating system or what other dependencies are needed, because these dependencies will already be part of that bundle or image essentially. And we could do the same for other apps as well, right? So here we just have one app, but I could create 5 more and we can do the exact same, create a Docker file for each one. And then we would have a bunch of Dockerized applications. So another word for those would be containers. And we want a container orchestration tool like Kubernetes to, for example, automatically scale up or down, right? Or automatically reroute to a healthy node. But to set up Kubernetes ourselves is very complex. So instead, we're going to deploy our applications to Acorn, which will use Kubernetes under the hood, but we won't need to know about that. We only have to deploy, and Acorn takes care of the complexity. So now that we have Dockerized our application here, how do we actually deploy it to Acorn? Well, you simply create another file, and that's called the Acornfile. Now, Acorn actually does have an extension in Visual Studio Code, so you can download that if you want. Unfortunately for me, it does not pick up this icon for the file yet, but that's okay. So in an Acorn file, you can describe all of the apps that you're gonna use, right? So if we go to our example here, we would have one Acorn file for everything, right? So Acorn ties everything together here, right? So if we look at this specific example, you can see that we're gonna use a database, and this is a Maria database, but could also be Postgres or MongoDB. This is a standard database, so there's already a Docker image online. So we don't have to specify all of this for that database. We can just grab the standard one from the registry. And then here we have our own custom app. So here under containers, we can describe all the apps that we have. And in this case, we will only have one. So we're going to build that from the current directory. So it will find this Docker file in the current directory. It consumes this database, meaning in the app here, we are indeed trying to connect to a database. We want to publish this port so we can connect to it. And then we have some environment variables that are needed in our application, right? So here we need these environment variables to connect to the database. So we need to inject that into our app. So with Acorn, it's actually very convenient to work with these secrets because Acorn will generate these secrets for you. And you can then easily reference them like this. So service.db.secrets.admin.username and also for password. So then these values will be injected so that our application can actually use them. And then here we have an if statement for only development. So our system right now is just 2, right? So in the example here, I had like 8 different microservices. And in this example here, we have 2, right? So our own custom app, and then this standard image that we're just pulling from the GitHub container repository, right? So we could add more apps here. We could have many more like what we had here. And you would just specify all of that here in one file, right? So the Acorn file is actually quite similar to a Docker file. And the syntax is also quite similar to JSON. So it looks quite familiar in many ways, and we don't need to use any YAML files or anything else. This is all that we need. So then I can go to the Acorn website and I can log into the dashboard, and here I have nothing yet, so this is going to be the empty view. So here we have 3 options, so I can click on this one, already have an Acorn. So what we're doing here is very similar as with the Docker file. So with the Docker file, from there you can build the image, and the image can be uploaded to some registry. And it's the same with an Acorn file. So also, just like Docker, you can create an artifact from this, and it can also be uploaded to a registry. So then you can deploy that here in the cloud by just picking that Acorn image from the registry. Now they also have some standard Acorns here for some common applications, right? For Postgres, MongoDB, Redis. Now we don't have an Acorn yet in a registry, and we also won't use this catalog for now, so I will cancel here. So we can actually also write the Acorn file right here in their playground. So we are doing it here in my code editor, but you can actually do all of that here in the dashboard as well. And it will actually automatically spin up an app here. I will stop this for now and we'll continue this later. You can see now we have some additional data here from the playground. I will delete it for now. So now we want to build this and then also run it. So I'm going to open up my terminal. So Acorn has a CLI, so once you install that, you can use Acorn commands here. So I can say Acorn run and then reference a name, and I will call that cool-example. So if I press enter here, it will build and then also run our app here. And that may take a couple of seconds, right? So you can see it's building it. Now by default, there will be an Acorn project actually, and it will put the app in there. So now here we can see the result of this in the dashboard, cool-example. I can open this up and it will show me the containers in here. So we can see there's a service here, the MariaDB service. And then we have our own container for our own custom app. And when you click on that, you will see the resources that it's using. Right, so here, CPU, memory, number of requests. Well, that should be 0 because we haven't gone there yet. So actually it will also immediately give us an endpoint here. Right, so here you can just click on that and you will be able to go to this project, and you can see now this is working. Right, so our app here basically consists of 2 services, right? So we have our own custom app and then we have a separate database, and I can now see if that works. So I'm gonna say test and we'll see if it actually inserts it into the database. Okay, so we see it here in the UI, but if I refresh, is that data persisted? And yeah, it's persisted, right? It's still there. And I can also mark this as complete, and I can also delete this. Yeah, right? So you can see how easy that was. And here I'm essentially just using 2 microservices, but I can do this with many apps, many little apps. I can get the benefits from Kubernetes. But you could see I didn't even write a YAML file. I don't need to know anything about Kubernetes now to make that work, because Acorn abstracts that away. Acorn worries about Kubernetes. You can forget about it as a developer. You can just focus on deploying apps. So here now you can see I can monitor these resources. I can see there has been a request, and you can see the other things as well. I can inspect the Acorn file here in the dashboard as well. Right, so what we get out of the box here is monitoring, logging, also secret management, right? Really beneficial here as well. But also things like auto scaling and debugging. So under the hood, Acorn uses Kubernetes, but you as a developer don't need to worry about that. You can just deploy apps without knowing anything about Kubernetes. So Acorn could be a game changer for you if you're thinking about using Kubernetes, or you're looking for an alternative because maybe it's a little bit too complex for you or the developers that you're working with. Well, maybe you want to consider using Acorn, or maybe you're just looking for a cloud platform to easily deploy your backend apps to. Well, you may want to consider using Acorn as well. So what we did here, this was all in my code editor here, but you can also go to this playground here, and here you also get an Acorn file. So here you can also describe that whole system, right? And you can do that right here in the dashboard actually. So as soon as you open this up, it will create an app for you. And one thing you can also do is share this with other people. So if you have an idea, you can just share this with other people. They can click and open this link, and it will open it up in the dashboard for them as well, right? And they can create an app for themselves out of this. So now it created this ancient bird app. So here now you can see it in the overview, ancient bird. Now with these apps, it will automatically give you an endpoint as well. So you can actually access it. So that's really beneficial as well. And you can see it's just a very simple Nginx server. And I don't need to worry about ingress or anything else. It's all handled for me under the hood. All right, so there's one more feature that I want to show you. So we were working on this cool example app. So one thing you can also do is you can go into dev mode. So I can simply say Acorn dev, and it will actually have live reload capabilities. So here it will run a quick build. All right, so then at some point it's finished, and I can click on this link here and open it up in my browser, and you can see I'm back to my app here. But now if I change the Acorn file or any Docker file that's connected here, I will set Flask debug to 0. If I save here, you can see it picked up on that and it will automatically rebuild. And the cool thing is, this is automatically synced as well here in production as well. Now they have some other cool examples on their website. So one of the things you can do is actually start up your own Minecraft server here with just one click. Right, so then you can deploy this here within Acorn. Right, it's a really interesting platform. Check it out. I want to thank Acorn for sponsoring this video, and I hope this was helpful. Hope that you learned something. Thanks for watching. Have a nice day, and bye.